Write the equation of the line. You can use y equals mx plus b for all of these to be formed into an equation. This one down here says the slope of the line is -7/4, and the y-intercept point is 0, -5/6. West Middle School is planning a field trip. Each bus can transport up to 35 students. Consider the relationship between the number of students attending the field trip and the number of buses needed to transport the students. Ethan created this table to represent the situation. Is this relationship a function? Why? Well, yes. Each input is assigned to exactly one output. You don't see 35 students needing one bus and also 35 students needing 4 buses. Each input goes to exactly one output. From the table, he determined that the function is linear. Do you agree with Ethan? Why? So from the table, it does appear to be linear. From the table, but it is not linear. And the reason is because any amount of students from 1 to 35 use one bus. But then from 36 to 70 need 2 buses. So it's not growing at a constant rate. Can you think of a rule that can be used to describe the relationship between the number of students attending the field trip and the number of buses needed? If so, what is it? Well, the rule would be the first 35 require one bus, the next 35 require 2 buses, and so on. Can we write an equation to represent the function relating the number of students attending the field trip and the number of buses needed? If so, what is it? Now, I'm not going to lie to you and say that there is no equation to write. But at this point in middle school, we don't have the formula or the template that would help us write this equation. This is an example of what's called a step function because you have a range of values that all fit into one bus, and then it jumps up to 2 buses for the next one. So this is called a step function, but at this point in time, we don't have any experience writing or creating an equation for a step function. What inputs make sense in this situation? Well, the inputs represent the number of students, so we wouldn't want to input any decimals or any negatives. So we want positive whole numbers. We want 0 and larger. Consider the relationship shown in the table. Is the relationship a function, and why? Banana has its own output, cat has its own output, slushy has its own output. Walk and sing all go to exactly one output. So yes, this is a function. What do you notice about the relationship? If it is a function, what rule describes it? Well, the rule is you're assigning the input the first letter. Can you write an equation to represent this function? No. Why not? We can't write an equation because the inputs and outputs are not numerical. Degrees Celsius and degrees Fahrenheit are 2 units of measure for temperature. Nora and Abdul recorded the temperatures of different cities around the world in both degrees Celsius and degrees Fahrenheit. Is the temperature in degrees Fahrenheit a function of the temperature in degrees Celsius? In other words, if we define the temperature in degrees Celsius as an input and define temperature in degrees Fahrenheit as the output, does the relationship appear to be a function? Explain. Yes, because each input in Celsius has only one output. At 9 degrees Celsius, it can only be 48.2 Fahrenheit. It can't be a different temperature. Graph the data shown in the table. So we started with 9, 48.2. So 9, 48.2. Then we had 18.75 and 65.75. Zero 32 and 25.77. Well, I know that the y-intercept is 32 because that's where it started. Let's go back and find the slope between 2 points. From 32 to 77, if we take y2 and subtract y1, that would give us a difference of 45. If we take x2 and subtract x1, that's a difference of 25. So that would be a slope of 45 over 25. But both of those are divisible by 5. So 9/5 is our slope. And 32 was our y-intercept. What values make sense for inputs in this situation? We can have negative temperatures and we could have decimals for temperatures. However, there might be some that aren't likely for cities. Because this was talking about temperatures in cities, you might restrict some of those. But we could have decimals or whole numbers, so any rational number or any real number. But you may try and say that you want it between this temperature and this temperature because it's unreasonable for a city to get up to 300 degrees Fahrenheit. You might restrict some of those values, but it would make sense to put in negatives or decimals or fractions in for your temperature. Use your equation from part C to determine the equivalent temperature in degrees Fahrenheit when the temperature is 45 degrees Celsius. So we're going to plug in our 45 degrees and convert it to Fahrenheit. 9 times 45 divided by 5. 81 plus 32 is 113, and that is degrees Fahrenheit. Another activity that may be done in class that you would miss if you were watching this video online is we would do a card sort, or we're trying to match the relationship to one of two categories. So some students may choose to sort this based on what is a function and what is not a function. Some students may choose to graph or separate their functions out based on whether they are numerical functions or if they have some qualitative aspect to it, a different type of characteristic like letters and words. You may also sort them into what you might think as a relationship that is linear versus nonlinear relationships. But ultimately, the goal of today's lesson is to look at different types of functions. And so you might want to choose to sort it based on things that are functions versus ones that are not. And that would be it for lesson 4. You can check back for more videos on module 6 in the playlist.